We're working in section 1.6. I have one more example of a radical equation. Notice this equation is a little bit harder than the previous examples because now there are two radicals in the same equation. So we're still going to use the same basic step. We're going to isolate a square root and then square both sides. And then we'll just have to repeat that step twice in order to get rid of both square roots. So let's go ahead and get started. Let's isolate this first square root of 4x plus 1. The way to do that would be to add the square root of x minus 1 to both sides. And then, since we have a square root isolated, we can go ahead and square both sides. And when we do that, on the left-hand side, the square root and the square cancel, and we've gotten rid of one of the radicals. On the right-hand side, we need to multiply out 2 plus the square root of x minus 1 times itself. That's a little bit tricky, so let's come out to the side and let's write it out. If we're going to use the distributive property, we need to multiply 2 times 2 and get 4, and then 2 times the square root of x minus 1. And then we need to take this square root of x minus 1 and multiply it by 2. So that gets us another term just like the previous. And then the last term would be the square root of x minus 1 multiplied by itself. And so then we can simplify this a little bit. Notice the two middle terms have the same radical expression. They both have the square root of x minus 1, so we can combine them together. They're like terms. Just add 2 plus 2 and get 4 times the square root of x minus 1. And then here at the end of the expression, the square root and the square cancel, and we're just left with x minus 1. And then we can simplify a little bit more. We can do 4 minus 1 together, makes 3. And then maybe we'll write the plus x next, and then we'll write the radical at the end. Although, you know, it doesn't matter what order we write these three terms in, as long as we have those three terms. Okay, so that's a little tricky. So let's go ahead and take that result and continue on with the problem. So 3 plus x plus the square root plus 4 times the square root of x minus 1. So we got rid of the square root over on the left side, but we did not get rid of the square root on the right yet. That's what we're going to start working on now. How should we do it? Well, we should isolate that square root on one side of the equation and then square both sides. So let's go ahead and take this 3 and subtract it to the other side. And take this x and subtract it from both sides. And then we have 3x minus 2 on the left. And we have 4 times the square root of x minus 1 over on the right. Now, I know I said we need to isolate the square root. Technically, that's not exactly true. You know, this 4 over here isn't really going to bother us. We could divide it off to the other side, but that will just make the next step a little more complicated because of the fractions. So let's just leave the 4 there multiplied by the square root, and let's go ahead and square both sides, and let's see how that works out quite nicely. So In particular, here on the right-hand side, what you have inside the parentheses is one factor multiplied by another factor. And if that whole thing is getting squared, then that just means that each factor is getting squared. So 4 squared makes 16. And then when you square the square root, those cancel, and you're just left with what was underneath the square root, the x minus 1. So we got rid of our other square root. Over on the left-hand side, we have 9x squared minus 12x plus 4. And so now we've gotten rid of both square roots. We have a quadratic equation. We can go ahead and solve it. Let's set it equal to 0 and then try to factor. So let's have 9x squared minus 12x plus 4 is equal to 16x minus 16. And then when we subtract the 16x to the other side, let me fit in an x that I had left off. When we subtract 16x from both sides and add 16 to both sides, then this is what we get. 9x squared minus 28x plus 20 is equal to 0. Now this factoring might be a little tricky because the numbers are so large, but let's give it a try. The coefficient on x squared is not 1, so that means we have to do factor by grouping. And so we need to take the 9 and the 20 and multiply them together to get 180. Factor by grouping says find two numbers that will multiply to 180 and also add up to negative 28. If we go through all the factors of 180, that would take quite a bit of time. So let's try to jump right in and find two numbers that look like they might work. 1 times 180 is not going to work because they don't add up to negative 28. And in fact, since the product is positive and the sum is negative, that means that the two numbers will both be negative. The two numbers will both be negative. The first thing I'm drawn to is 9 times 20. If we make them both negative, then we get the product that we want, but the sum is not quite right. It's off just a little bit. So that won't work. But we're getting close. What about negative 10 and negative 18? That should do it. Okay, so let's come over here and let's rewrite the middle term as the sum of two terms, minus 10x and minus 18x. We'll bring the rest of the problem down. And then remember, we just need to factor from the first two terms. They have an x in common. And from the next two terms, they have a minus 2 in common. Each time you factor, it's always good to check that it's correct by multiplying back out to make sure you get the expression that came before. Okay, now that we have these two terms here that both have the same factor, 9x minus 10, then we can factor that out, and we just have x minus 2 left over. And so when we set the two factors equal to 0, we get our two solutions. We get x equals, let's see, add 10 and divide by 9. So 10 over 9 and x equals 2. So that's pretty good. Let's back up for just a moment and let's look at the steps again. This problem was harder because it had 2 square roots in it. And so we had to isolate one of the square roots and then square both sides. That's what we did right here. We isolated square root of 4x plus 1, squared both sides. We got rid of that square root. The other square root was still there. So then we had to go through the process again. We had to go ahead and isolate that square root. Here it is isolated right here. And then square both sides. And then that square root goes away. And then we're just left with this quadratic here, which is a little bit harder than some of the quadratics we solved earlier. But it's a nice problem. We can solve it the regular way. Set it equal to 0, and then do the factoring, and then get to our 2 solutions. Do you remember there's one more step we have to go through? We still have to check our answers. Since we had square roots in the original problem, we said that it's possible to introduce an extraneous solution, a solution that looks good at the end of all our work, but in fact it's not. And so how do we find out if it's really good or not? We check it. So let's go ahead and check the 2 answers. Let's check x equals 10 over 9 by substituting it into the original equation. So we'll have 4 times 10 over 9 plus 1 minus the square root of 10 over 9 minus 1 is equal to 2. And that's a question. It's important for us to be good at multiplying and adding fractions. Under the first radical, we have 4 times 10 over 9, so that's 40 over 9. And if we want to add 1 onto it, we need a common denominator of 9. So 40 over 9 plus 9 over 9 would work. Similarly, under the second radical, 10 over 9 minus 9 over 9. And then we can see we have 49 over 9 under the radical minus 1 over 9 under the radical is equal to 2. It's still a question. Remember, if you want to take the square root of a fraction, you take the square root of the numerator and the denominator each separately. So square root of 49 is 7, square root of 9 is 3. 7/3 minus, over here on the next fraction, we get 1/3 is equal to 2. And sure enough, that's true. 6 over 3 is 2, and so that worked out. Great. Let's go ahead and check the other solution. Let's check x equals 2. Let's plug it in. This one will be a little bit easier without the fractions. And under the first radical, we get 8 plus 1 is 9. So the square root of 9 is 3. And under the next radical, 2 minus 1 is 1. Square root of 1 is 1. 3 minus 1 is 2. Yes, that's true. And so x equals 2 also worked. So in this example, we had 2 solutions. We had 10/9 and also 2. We just don't know if the solutions are going to work or not until we plug them back in at the end of the problem. You know, in this case, both solutions were valid. In another example we saw, one of the solutions worked, but the other one was no good, and we had to throw it out. And then it's also possible that neither of the solutions is good, and in fact the equation has no solution at all. So lots of possibilities.